In this demonstration, I'm going to talk about the Tabor Quantum Physics Starter Pack. It consists of the Proteus 1.25 gigasample arbitrary waveform generator and the Lucid 12 GHz RF signal generator. To make the demonstration work, I'm also using a quantum microwave IF mixer. So we've got the arbitrary waveform generator feeding the IF input, and we have the signal generator feeding the LO. And we're using the optional digitizer today on the Proteus arbitrary waveform generator to show some of the signals that we're going to generate. I'm using a couple of pieces of software today to control the instrumentation. Everything is controlled through USB, so it's very easy to set up. I've got my Wave Design Studio software here, which allows me to create waveforms and experiment with waveforms. At the same time, it also shows me the Skippy language or the SCPI language that we want to use if we're writing a Python or a MATLAB control system for this instrumentation, so I can just directly learn from this software which commands I'll need to do when I get to designing the full system. I also have the digitizer connected up, so we have the time domain waveform here and the frequency domain spectrum on the bottom. So first thing I should do is go to the Lucid control software. So I've got it set to about 7 GHz. Input power to the local oscillator is 10 dBm. The range of the quantum microwave mixer is from 8 dBm up to about 13 or 15 dBm. Designed for low noise applications. So let me switch that on now. And you can see at the bottom here in the frequency domain I have some LO feed through. Pretty low, which is good. So why don't I now go to Wave Design Studio and select some modulation. So first of all, let me select some low frequency modulation. Click on here, so I'm selecting this time domain waveform, and if I look at it on the digitizer, you can see now that we've superimposed the amplitude modulated signal of this onto the carrier wave, which is at 7 GHz. And if you look closely here, you can see that there's some sidebands. Why don't we use a sine wave of a higher frequency now? And now you can see our sidebands are much further apart. As you can see, we have the LO feed through, we have the lower sideband, and we have the upper sideband. The lower sideband is higher in amplitude than the upper sideband, and that's by design with this type of mixer. What we should do next now is create a Gaussian pulse and then modulate that onto the signal. So I think I have got one saved here in this waveform, and there you go. Now you can see here in the time domain signal I've got a string of Gaussian pulses. You can see them here in the frequency domain, plus and minus the 7 GHz carrier. I can also do different sequences of modulated pulses. I can change the phase of each one, by pi over 2, consecutively. I can create a reasonably good quantum control and readout system with this bare-bones system here of the Lucid RF signal generator with frequency range up to 2 GHz and the 1.25 gigasample arbitrary waveform generator, what we call Proteus, both from Tabor Electronic. Thank you.